And in this one, we will be going from grams to moles, moles to moles, and moles back to grams. And of course, that will be a three-step conversion type of problem. Okay, so first we have to have a balanced equation, and in this equation we have potassium, which is +1, a phosphate, which is -3, a calcium, which is +2, and a hydroxide ion, which is -1. So calcium is going to combine with phosphate, and then we have hydrogen reacting with hydroxide. HOH, the same thing as good old high quality H2O. So now we will put the charges back over the top, crisscross the charges if they are different from each other, and then we will balance the equation. So here we go, we'll balance from left to right and do the arrow sign, and then we'll go back and double check. So we have 3 hydrogens there, so we'll need a 3 on the product side, 1 phosphate and 2 phosphates on the product side, so we'll put a 2 next to our phosphate. Now it'd be tempting to go back and try to adjust hydrogen, but we need to go all the way through first one time and then go back and double check. So we have 1 calcium on the reactant side, we have 3 on the product side, so we'll need to put a 3 there. 3 times 2 is 6 hydroxides, so we'll have to change this coefficient to a 6. So let's double check. 2 times 3 is 6, 6 hydrogens. 2 times 1 is 2 phosphates, 2 phosphates, 3 calciums, and 3 times 2 is 6 hydroxides and 6 hydroxides. So now we are balanced. This particular problem says how many grams of water can be produced when 75 grams of phosphoric acid reacts with excess calcium hydroxide. All right, so we are solving for water here, grams of water, and we are given 75.8 grams of phosphoric acid. So we're given 75.8 grams here, and we are going to go to grams of water. So grams to grams type of problem. As always, we'll write down our given, which is 75 grams of phosphoric acid, H3PO4. So we're going from grams to moles, moles to moles, and moles back to grams. So 3 different steps here. So I have 3 conversions, grams to moles. Whenever we have grams and moles together, it'll be 1 mole, then moles to moles, and then moles back to grams. Moles here, I'm color coding it. 1 mole is equal to so many grams of H2O. And then we have moles on the bottom here, moles of H3PO4. All right, this is H3PO4. Okay, so a 3-step conversion. And so now we just got to fill in our values. The first one is grams of H3PO4 per moles of the same. So whenever you go from grams to moles, you need the molar mass off the periodic table. Have 3 moles of hydrogen, 1 mole of phosphorus, and 4 moles of oxygen. 16, 31, and 1. 6 times 4 is 24, be 64 there. 4, 5, 6, 7, 8, be 98 grams per mole. 98 grams per mole. All right, so now if we were to leave it there, we would just have moles of H3PO4, but we've got to change from moles to moles right here in our next step. So how many moles of H3PO4 according to the balanced equation? Well, there's 2 moles of that guy. And how many moles of water? We have 6 moles of water. 6 moles of water. And for every 1 mole of water, we have so many grams. 2 times 1 will give us 2 grams of water. Oxygen, 1 times 16 will give us 16 grams. So we have 18 grams of good old high quality H2O. A lot of work there, but the steps aren't any more difficult than the other problems that we've done. So now we need to multiply across the top and divide by the bottom. So I get 41.3. So our answer here is 41.3 grams of water. Okay, so we have another problem coming up. Why don't you try to work that one and then pause the video and work that one, and then we'll come back and discuss it. Okay, hopefully you did that. So let's work this one. Why? Because it's so much fun. We have 156.8 grams of calcium phosphate, and this is grams of calcium hydroxide, so it's another three-stepper because it's grams to grams. I won't try to color code this one. And so we have grams of calcium phosphate on the bottom. Whatever you start off with here has to go on the bottom so it'll cancel out per 1 mole of calcium phosphate. And we have moles of calcium phosphate on the bottom, and we are going to go to calcium hydroxide. So we'll need moles of calcium hydroxide on the top, and then we'll need moles of calcium hydroxide, 1 mole per grams of the same. Okay, yep, there we go. All right, so grams to moles, and moles back to grams. So we need to figure out the molar mass of calcium phosphate. So let's do that. Ca 3 moles of calcium, 2 moles of phosphorus, and how many moles of oxygen? 8 moles of oxygen times 16, 31, and 40.1. So that'd be 120.2. That'd be 62. 6 times 8 is 48. 8 times 1 is 8. 9, 10, 11, 12. 128. 2, 10, 11. 310.2 is what I got. You double check me and make sure. So now we're at moles of calcium phosphate. So how many moles of calcium phosphate are there? Well, if there's nothing there, it's understood to be 1. So for every 1 mole of calcium phosphate, how many moles of calcium hydroxide do we have? So let's find that guy, and we have 3 moles of calcium hydroxide. And so for every 1 mole of calcium hydroxide, how many grams do we have? Okay, so we'll have to do that one. So this one, calcium hydroxide, has just 1 mole of calcium, 40.1. Oxygen, we have 2 moles of oxygen times 16 will give us 32 grams. And then hydrogen, we have 2 times 1 will give us 2 grams there. Add all those up. 2 and 2 is 4, and 74.1 there. Okay, 74.1 grams. Getting a little sloppy there, but let's circle everything here. So we got 156.8, we've got 3, and then we've got 74.1 on the top. 310, and 1 will not change anything, because multiply anything by 1 and you get that number. So it'd be, I get 112.2. 2 grams of calcium hydroxide. Okay, so kind of a long process. Not any harder than anything that we've done before. Just takes a little bit more time, a little bit more patience to work those problems.